So larger two large parallel plates with emissivity zero point 0.3 and zero point 0.8 is set to exchange heat between these two surfaces. And suppose say that the plate 1 is at a temperature say 400 Kelvin and 2 is at a temperature 200 Kelvin. So temperature will be given. So we should change that to Kelvin. Then first thing is, if two plates are there and there is in some cases we insert a small thin film in between these two plates, and that small film is called shield. Why we call them shield is because of this introduction of this small thin plate we are able to reduce the radiation heat transfer, so we call them a shield. And here, if there are two plates at temperature say T1 and T2, and sigma will be given in the question, and if sigma is given, then the radiation heat transfer between this plate 1 and plate 2 can be found out as sigma T1 raised to 4 minus T2 raised to 4 divided by 1 by epsilon n. This is the emissivity of the plate 1, that is epsilon n is 0.3, and 1 by epsilon 2, that is 0.8 minus 1. So if we have two plates, then it is how we find this one, the temperature heat transfer. So suppose say we have another plate here and it is 4, so its temperature is T4, and here it is having a temperature T1 and it is having a emissivity epsilon 4. Then if we are finding the heat transfer between 4 and 1, then what we do is sigma into T4 minus T1. Only the parties engaged are 1 and 4, because we are finding the heat transfer between 1 and 4. In between them there is no parties, so we will only take 1 and 4. So here we will get E4 and E1. So that's how we change it. Now, so here in the previous case it was E1 and E2, so it is like T1 and T2. Now what we do is, this is the, so here we are having two plates at temperature T1 and T2, and so emissivities are epsilon 1 and epsilon 2, or E1 and E2. Here we are introducing a third plate. So when we are introducing a third plate, this is actually, we can say that this is the resistance between these two plates. So now if we are inserting a third plate, then we are having the resistance due to this 1 and 3, and then because of this 3 and 2. So again, if we are considering the heat transfer, then between 1 and 2, then here we are considering the heat transfer between 1 and 2, that is equal to sigma T1 raised to 4 minus T2 raised to 4. But here look, 1 by E1 plus 1 by E2 minus 1, when only 1 and 2 are present. But when 3 is present, first we should write this term for 1 and 3, that is 1 by E1 plus 1 by E3 minus 1. So this is over. Now we will take this part, that is 1 by E3 plus 1 by E2 minus 1. So this is over. So we can find the heat transfer with the shield. So when doing it, we will get this is some 200 and this is some 100, that is there is a change in heat transfer. So if we are taking this Q12 minus Q12 shield with the shield, that is this one, divided by Q12 into 100, we will get how much percentage of reduction is there in heat transfer. Now here we have considered the heat that is transferring between 1 and 2. That is actually from 1 a part of heat will be reaching 3, and that will be going to 2. So from 1 to 2, 3, there will be a heat transfer. That is similar to the heat transfer from 3 to 2. That is similar to the heat transfer from 1 to 2. So 1 to 2 we have formed the heat transfer. Now say that we are going to find the heat transfer between 1 and 3 only. So we are having two plates, 1 and 3. In between there is no anything else. So we will only consider 1 and 3. There we have Q13 is equal to sigma into T1 raised to 4 minus T3 raised to 4 divided by 1 by E1 plus 1 by E3 minus 1. There is not any plates in between 1 and 3, so we only consider, but this will be equal to this one, because whatever heat that is transferring from 1 to 2 should pass through 3. So it will be same, these two heat will be same. So this can be used when we are asked to find the temperature T3 of the shield. If something is asked like find the temperature of the shield, then this equation can be used. Usually they are asking this percentage of reduction, so we can use first this equation, that is without shield. Then with the shield we will use this equation, and then we will find this Q1, the both heat. Then there will be a reduction of heat when we are considering this case. That percentage will be found to get the percentage reduction of